in the slides with all the detailed steps, the exact R specs, everything that Luisa did, documented in full so you can do it yourself. And as Heidi mentioned, connecting different kinds of resources, InstaGenie, ExoGenie, Planet Lab, EmuLab, and connecting to non-GENI resources. To borrow an example that Ilya mentioned at the demo night, when you have a large data set on a non-GENI host and you want to compute on that inside your GENI slice, you want to be able to transfer that data over your data plane. So you can create a stitch to a non-GENI resource, transfer your data into your GENI slice to run your experiment over or just to process. And you saw us do that connecting across Scenic to a machine at Stanford. Creating circuits isn't new, but it's hard. You've seen this at demos in the past at GEC, you've seen it at other venues, but it takes a lot of work. The network engineers and the network operators have to go through and figure out where there actually are wires, what are the endpoints, what are the available VLAN tags, coordinate that with the compute resources, the GENI virtual machines or bare metal machines, and then the actual debugging. And the result is weeks of work and grief, typically. And then, of course, after your demo, typically it goes stale and goes away. But you saw Luisa do it in minutes. And you can do this yourself with the instructions that Luisa has posted. As Heidi mentioned and Luisa mentioned, there are specs, and the R specs are posted. But there's nothing fancy about it. If you have reserved 2 compute resources before, you've basically done what's involved in stitching. All you have to do is say, I want a machine, I want another machine. In this case, I want them at different aggregates, and please create a link between them. And that's it. Your tool and the aggregates do the rest of the work. So how does that happen? What goes into that? Well, it happens sort of in 2 time scales. There's the longer time scale that Heidi was talking about when the new rack gets set up, the work of weeks. And then there's the shorter work that you saw Luisa do that happens live and is pretty easy. And I'm going to explain a little bit of what's going on under the covers for both of those. So the first step is to create a stitchable network, right? Actually connect the wires. And that's the work of the network operators and the engineers that happens in advance, happens over the course of possibly weeks, but it happens once per rack. And once it's done, it's ready for the experimenters. And this replaces all of that manual work of creating circuits that we have done on behalf of experimenters in the past years in GENI and that you've seen happen elsewhere. Well, what is that work? Where are the connections? How can I get from this GENI aggregate to the others? And typically that means identify the national backbone that you're going to connect to, and that usually means going across the local campus, across a regional, and then to the backbone, and from there you can get to the other GENI aggregates that you might want to connect to. What are the endpoints? What are the switches? What are the actual ports where the wires connect? What VLAN tags are available? You have to gather all that information. And as you see in the middle there, we've got a couple of networks. How do the networks play in setting up the GENI circuits and the overall GENI network? And there's sort of 3 ways that typically a network might be involved. And as Heidi says, there's one that we think is probably typically the most popular. You can run an aggregate over a network. If the network creates dynamic circuits, then you can do something like the aggregate we have over Oscars, and the aggregate on demand creates dynamic circuits. For a network that doesn't do dynamic circuits, does static networks, then the aggregate essentially is giving out VLANs that it is set up on demand. And the final option is the network doesn't have to run an aggregate at all. Instead, what it does is it delegates the VLANs to the GENI aggregates at the endpoints, and they're responsible for controlling who has access to these VLANs. So as Heidi mentioned, we've got this process we're prototyping for delegating VLANs. This is work prototyped by Tom Lehman and Ji Yang of Max. But basically, you've got a file, some XML for capturing the fact that this switch, this port, goes across this regional network to get to this other switch and port, and these are the VLANs, and this is the capacity of the link. And that then can be fed into a wiki page. It can be fed into experimenter tools, into monitoring tools, so that the operators can know how their VLANs are being used, so experimenters can know what networks they're actually traversing in their experiments. And the little snippet that you still can't read, in this case, it's saying that to get from the InstaGenie GPO rack to ION, we traverse NOx over a link that's got a particular capacity and a VLAN range of a few VLAN tags. So if you've got all of that information, now you actually can configure this, the network operators and engineers configure this for us. In the case where the network does dynamic circuits, we're talking about configuring Oscars, configuring the aggregate manager, and then waiting for the experimenter to arrive. In the case of static circuits, you can run an aggregate, or you can delegate them, but either way, you have to set up those VLANs so they are up and running and waiting for the experimenter. In the case of InstaGenie GPO, that means setting up the connections across BBN, across NOx, who delegates VLANs to the GENI aggregates, and then into ION, who will be ready to set up dynamic circuits and Oscars. So a little side note about that. We have an aggregate that runs over the ION service at Internet 2 for creating dynamic circuits and doing VLAN translation. This was written by Tom Lehman and Ji Yang of Max. It's an SFA-based aggregate. But basically, what it's doing is translating GENI calls into Oscars calls. Turns out that that's a fairly easy translation. There's some magic here, but it's pretty powerful. Where networks that run Oscars can run this aggregate. This isn't specific to Internet 2. And the result is that you give GENI experimenters the ability to create arbitrary GENI ION endpoints in circuits on demand. And this is also one of the ways that we create circuits that get to non-GENI resources. That's the work of maybe weeks in advance by the network engineers and operators as you bring on a new aggregate. What happens when the experimenter shows up? Well, the experimenters don't have to worry about that, all of that pre-configuration. It's already done for you, and we showed what happens, what the experimenter sees in the demo. So I'm going to dive in a little bit what the tool was doing, what the aggregates are doing when Luisa was reserving those resources. The thing to remember is that what Luisa as an experimenter had to see and had to do, pretty simple, and it just works. The experimenter just says, these two nodes, I want a link, they're in different aggregates. That's it. Everything else is handled for you. So here's a picture of what the process I'm going to walk through. It starts with a request, fairly simple request. The experimenter gives that request to the tool and then waits. The experimenter's job is done. The tool first finds a path. How do I actually connect aggregate A to aggregate B, possibly using the stitching computation service. And then the tool goes and talks to the aggregates, just reserving resources. So the tool goes and reserves resources at the different aggregates, pulls the answer together and tells the experimenter, congratulations, you have a circuit. But all of this, the experimenter's job is fairly simple. Design your experiment. Decide that you want a couple of nodes, each with an interface, and you want them connected. So you work with your tool to create an RSpec that has this link and that says, and this is a link between two aggregates. And then you have a full RSpec now for your full slice, essentially, and you're done. Experimenter's job is done, and the rest is done for you. What does the tool do? Well, the thing to remember, and I'm going to go through the steps of what the tool does, is there is no central magic GENI stitching process. Stitching is just a set of resource reservations. There are tools They work on behalf of experimenters, and all they do is reserve resources at aggregates. Nothing special. Any tool can do this. We used an Omni script because that's what I work in. But better tools will do this even more simply for experimenters. And as Heidi mentioned, the FLAC support for this is well underway. Luisa mentioned a few steps, and that's roughly the steps I'm going to explain for what it is that the tool does. You have to find a path. How do I get from aggregate A to aggregate B? Come up with what the request is that you need to submit to each aggregate. The tool finds the path, it constructs the request RSpec, and then it submits the resource request to each of the aggregates. If there is a dynamic circuit in the mix, if you're reserving a circuit across ion, you have to wait to see that circuit comes up, and then report back when you're done. All right, let's dive in a little bit. So we started with our simple request, and now we need to find a path. Well, that typically means going across some intermediate networks, going across some intermediate aggregates, and looking to see maybe what VLAN tags are available. How does the tool do this? Well, aggregates advertise how they are connected. The tool then looks at these, pieces together this topology, and finds the possible paths between your two endpoints, the possible VLAN tags, and then thinks a little bit about the right way to talk to the aggregates, the right order, because order can be important in your chance of success. Some aggregates want to be the one to pick the VLAN tag that they're going to use on their switch. Some aggregates do VLAN translation, and they really don't care what VLAN you're connecting. So the tool can optimize your chance of success, do all of this for you. And there's a little picture of the path that Luisa's demo used. But doing even all of this can be hard. There are a lot of heuristics to do it well. So there's a service that can support this. The stitching computation service does the path computation and the workflow computation, has a bunch of heuristics. It can do things like you can ask it to exclude a particular switch that you happen to know is acting flaky, or VLAN tag that was unavailable. Tom Lehman and Ji Yang wrote this service, but it's optional. All it's doing is adding some XML to your RSpec, adding some data, specifying the path that you want. Any tool can do this, and you can do it in a different way, maybe that's more optimized for your experiment or for your tool. The Stitcher tool used this stitching computation service. How do the tool and the Stitcher talk? How do the tool and the aggregates talk about circuits? They use an RSpec extension that we adopted and published, the stitching RSpec extension. It does a couple of things. If it's an advertisement from an aggregate, this is how the aggregate says, I have a switch, I have a port on that switch, and without that cable, I've configured a few VLANs, and the thing at the other end is this other switch and this other port. In a request, you specify the request that's been expanded by the tool or by the computation service. It says, my link is going to start at this switch and this port, going to go out this VLAN. Then the next switch in line is this other one, and then the next switch until I get to the other aggregate that the experimenter wanted resources at. In the manifest RSpec, it just fills in, and this is the VLAN tag we're going to use at each spot along the way. So this is the language that the tools and the aggregates talk through. At this point, your tool has your path computed, and now it's going to go reserve resources. VLANs and circuits are just resources like any other. So you reserve them using the GENI Aggregate Manager API's create sliver call. A slight difference, as I mentioned, is that the order of the reservations can make a difference. So the tool handles that using that workflow that it computed or that the stitching computation service computed for the tool. And then in the case of Stitcher, it's just calling the standard Omni calls to reserve resources. What does the aggregate do? Well, as with any other resource request, it looks at your request to make sure it has the resources available. Does it have a node? If you ask for a VLAN, does it have a VLAN available? And then it configures the resources for you. It stands up your virtual machine if that's what you asked for. And if you ask for a VLAN, it configures the switch to have that VLAN tag get to the new interface on your virtual machine. And that's some of that work that Heidi mentioned that the rack teams have done, is so that the aggregates are capable of doing that. When the aggregate's done, it returns the result just like any other resource request. And the tool gets the result and looks at it and says, okay, great, you've got a node. In the case of stitching, there's a little more. You've been assigned a VLAN tag, and the tool wants to know which VLAN tag. Because, for example, if InstaGenie GPO, as in the demo, picked tag 3747 for your circuit, you better tell ION that at the InstaGenie GPO side of the circuit, we want to talk on VLAN tag 3747. So the tool does a little work to create that per aggregate request. And things can go wrong, and the tool can handle them. You saw that happen live in the demo. The tool tried to request a particular VLAN tag from InstaGenie GPO. The tag wasn't available. The tool responded, tried a different tag. And so a lot of the typical kinds of errors you see in stitching, the tool just handles for the experimenter. And sometimes, if you ask for a resource that simply doesn't exist, if you ask for a Planet Lab node at an Emulab machine, you're going to get an error, and the stitcher or whatever your tool is going to complain to the user that they're doing the wrong thing. But in the most things, Stitcher handles the problems. Dynamic circuits are a little different. They take time. You have to wait for Oscars to configure all these routers. This is real work going on. And things can fail, as Luisa mentioned, and the tool can look to make sure that your circuit comes up okay, came up okay on the first try for Luisa in the demo. But if it doesn't, it'll keep trying, and the experimenter just sits back and waits for the circuit to come up and be ready. And when it's ready, you have your circuit, and you have your connection, connecting your resources. What do you have? Well, the details usually aren't very interesting. You have particular VLAN tags, you have particular switches and particular ports. But we collect all of that information and make it available so the tool can draw a pretty picture. As you saw in the lab wiki, you can draw pictures based on this kind of thing. The stitcher also, though, makes a note of which aggregates you got a reservation at. You may not have noticed at the end of when Luisa did the reservation, it told you you've got reservations at 4 aggregates. And Luisa only asked for things at 2 aggregates. She asked for something at InstaGenie Utah and InstaGenie GPO. She ended up with a reservation at 2 different aggregates for some of the networks along the path, at ION and at Protogenie Utah, because that's the path that you take to connect those 2 racks. So that's some of the thing that that's reported back to you, and then you do your experiment, as Luisa did. There's a lot that goes on there, but Luisa didn't have to worry about it. You don't have to worry about it, and it happens quickly. Well, where are we going to go? We're not resting on our laurels. As Heidi described, there's testing going on. We're working out the final kinks, working with our early network and aggregate partners. And when we finish working out these kinks, that map of all of the sites where you can do this is going to get a lot busier. And that includes additional providers. We'll be working with NLR. We'll be working with additional regionals and campuses, as Heidi mentioned. And we'll be working to expand the set of VLAN tags that are available. Right now, VLANs are a scarce resource. You can ask, but if everybody in the room is doing this, they might not be available. So as we discover that we're using up and making such great use of all the VLANs, we'll be working with the regionals and the campuses to get additional VLANs. And how are we going to know this? Well, we're going to have monitoring so we can see that the VLANs are being used and that GENI experimenters are making great use of the networks. We'll also have monitoring to ensure that the circuits that have been pre-configured on all the racks are actually available, so the experimenters don't have to worry when they're ready to do their experiment, and things will just work. There's a new version of Omni, and that includes some improvements to Stitcher, like support for stitching to ExoGenie that will be coming out soon. FLAC, the new version of FLAC, adds support for stitching. You put two nodes on, you draw a link, you look at the properties of that link and say, I want that to be a stitched link. That version of FLAC will be rolling out soon as we work out the kinks in that. And then we can add support for stitching and other tools. Again, there are a lot of command lines, and for those of us who like that and like that level of control, that's great. And for experimenters who don't, they won't have to worry about it. There will be the nicer tools that will make all of this even easier, and certainly easier to demonstrate. And then there'll be other kinds of circuits. As Heidi mentioned, we'd like to allow you to have VLANs where the routing decisions at points along the way can be made by your OpenFlow controller. That requires primarily a bunch of network engineering. And then we'd like to support multi-point circuits. And again, that's something that we've been talking about amongst the developers for a while, and we hope to roll out in coming months. Bottom line, we've had the ability in industry and in parts of GENI to do pieces of this before, but we're making this more broadly available and easier to use. GENI stitching gives experimenters the ability to create custom circuits on demand and across all of GENI. GENI is about providing, in large part, the experimenters custom topologies in which to do their research cross-country, and GENI stitching is making that easier, and it's getting bigger, and it's getting easier. So with that, we have time, and if anybody would like to ask questions here, you can. But as Heidi mentioned, we will be talking about this as well in the operations track in the last session this afternoon. And I will also talk about this or entertain questions about this in the developer session at the same time at the end of the afternoon. Does anybody want to ask questions, or you want to mull it over and ask them in more detail in a smaller venue? Okay, thank you.